And a lot of these, so here's what I'll tell you. There's really two main things that we can prove if it's not already marked. Okay, what are those two things that we can use almost every time if we have it?
Vertical and reflexive.
Vertical and reflexive, okay? Reflexive means they have a shared side. If the two triangles are separated like this, they don't have a shared side, right? But here, these have a shared side, right? If they have a shared side, we know that side to be congruent, because if I did separate them, this side would be the same on both of those triangles. That's really the way we want to think about it. So if you have a shared side, that side is always congruent, okay? And usually if we were doing a proof, we would say because of the reflexive property and all that, which is true. But for this one, we're just marking it and saying, can we prove it congruent? And then we just have to look at the pieces, right? We have an angle, a side, and an angle. And we're going to go in that order. And that's my theorem. Okay. What I will also say is that 3 pieces may not always be enough. So just because you have 3 pieces, I think there's one later on here, that does not necessarily mean that the triangles are congruent. So 3 pieces is not always a dead giveaway. Okay, on number 2, how many pieces do we have? How many are marked right now? 2. What other piece do we know to be congruent? The reflexive side, okay? Over and over and over again, we've seen that, okay? The reflexive side is almost like a given side because we've seen it so much, okay? We should be able to identify that really easily because they share that side. And so now we don't have any angles marked, so this one should be easy, right? All 3 sides are marked. So this would be side, side, side. Okay, down here, how many pieces do we have marked? 3. Okay, so then we just have to decide, are those 3 pieces enough? There would be nothing else I can prove here. If the 2 triangles are separated, there's nothing else I'm going to be able to prove. There's no vertical angles and there's no reflexive property. If I don't have enough given to me on the pictures as it is, then I'm going to have to say no, not congruent. Okay, so here we have an angle, we have a side. Okay, so this would be, and make sure it's the same on both, okay? Because this one might be an angle side, and maybe over here, maybe it's the side between, okay? But here, both of them are angle side, but you would want to make sure both triangles are the same. Okay, number 4, once again, what piece is not marked that we know? Reflexive. Okay. Now, just because there's a 90-degree angle here does not automatically mean that is HL. Okay, it could be HL. We know we can use HL because there's a 90, but it doesn't automatically mean we have to use HL because there's a 90. We could use any of the other theorems too. We could use angle side angle or side angle side or any of those. But we have a 90. What side would this reflexive side be? Hypotenuse, because it's across from the 90 in both cases. And then the leg is the side that touches the 90 in both of those. So this one would be the HL. Okay, number 5, is there another piece that we can prove congruent? Because right now we only got 2. 2 is not enough, ever. Vertical angles, okay. Are there any other pieces that we can prove congruent here? No. Okay. So some people said something like these 2 were congruent. Maybe, okay. They look like they could be, but here's the thing you got to remind yourself is unless we have some way of proving that, we can't just say, yep, those are congruent because they look like it. Okay. Same thing for these angles. Sometimes we might be able to prove these angles are congruent, but I would need to know I have parallel lines or something like that. Here, that's the only angle I can prove congruent because of vertical angles. I got 3 pieces, so that means we can prove the triangle is congruent, right? No. Pay attention to the pieces that you have. This is side, angle. Do we have a side-side angle relationship? Or an angle side-side relationship? No, neither one of those exist, okay? So just because we have 3 pieces does not necessarily mean we have congruent triangles. Okay. And what I'll continue to tell you too, that doesn't mean those triangles aren't congruent. We just can't prove they're congruent. There's a completely different thing that goes along there, right? I need more information to be able to prove it. We're trying to prove they're congruent. That doesn't mean that they're not. I just need more information to get there. Okay, number 6, how many pieces do we have congruent? Got 2, okay? Parallel is not congruent. Parallel is parallel, right? It's telling me that these 2 lines will never cross one another. If we have parallel lines, the one thing that you always want to remember is the stuff that we talked about way back when. Parallel lines form all kinds of angle relationships. They form alternate interior, same side interior, corresponding, alternate exterior. All of those angles could be in play, okay? And we've seen a couple of them. The one that we've seen most common has been alternate interior angles, probably, in this chapter. And we'll see some alternate interior angles. But because these 2 are parallel, this would be our transversal. And so as I look at my angles here, what kind of angles are those? Corresponding, okay? Corresponding angles would be like these 2 angles here. One's on the inside, one's on the outside, but they're on the same side of the transversal. And as I look at my pieces, I now have 3. I have an angle, I have a side, and I have an angle. So this would be angle, side, angle. Okay, number 7, once again, what piece of information is not marked that we already know? Reflexive, okay? I can't stress that enough, guys. I mean, we see that over and over and over again. If we miss that on the test on Thursday, that means we just haven't been paying attention, because if 2 triangles share a side, we know that third side is always congruent. Every time, okay? And most of the time, I'm going to need that third side to prove, because right now I only got 2 pieces. I need that third piece to prove. So now do we have enough to prove? Well, I got 3 pieces, but we got to pay attention to the path that we have. Here we have side, angle, side. Pay attention to the order of the pieces. So this would be side, angle, side. Okay, earlier today, somebody did this. They said, oh, well, this is the midpoint, so I also know these are congruent. Can't I do side, side, side? What do you guys think? Could I do side, side, side because this is the midpoint?
No, it doesn't state.
It doesn't say it's the midpoint, right? Could it be the midpoint? Yeah, probably is. Do we know that for sure? No. It has to tell you that this point is the midpoint. Okay? We don't know that. We've seen ones like that where it is the midpoint, but we have to be given some information. So don't just assume, and that's where it's hard, because we have done ones like that where it was the midpoint, but every problem is different. You can only go off the information that is given for that one particular problem. On this problem, we don't know for sure if this is the midpoint, okay? So that's where you gotta be really careful. Don't just make up stuff unless you can absolutely 100% prove that piece of information. Okay, number 8. Reflexive property again, okay, over and over and over again. Do we have any angles in here that we could prove? Here's another one somebody tried to use earlier today. They said, well, these angles would be congruent because this bisects it. Maybe, right? Do we have any information that says this bisects this angle? No. Okay. Could it and probably does it? Yeah. But we can't just make it up. Okay. It looks like it probably does bisect it, but we don't know that for sure. Okay. So unless it's stated that it does bisect it, we can't just assume that to be true. We can only use the information that we absolutely know. And so this one would be side, side, side. Okay. On number 9, do we have enough as it's stated right now? As it's marked. Yeah, we got 3 pieces, right? If I have a 90, our first instinct, our first thought is probably the HL. This is a hypotenuse, this is a hypotenuse, this is a leg, and So this would be HL. Okay. Now, I told you that on some of these, there's more than one. What other piece of information do we know to be true about this one? Vertical angles. So I also know this angle and this angle are congruent. Okay? And I tell you that because now we could do angle, angle, side on both of these. Okay? So if you put angle, angle, side on here, would it be okay? You bet. Okay? But for me, I would just say use what's provided first. But if you did use angle, angle, side, there's nothing wrong with that. Could I do side, angle, side here?
No.
We have two sides in an angle,
But it's not
but it's not in the right spot. Okay, I would need to know the angle between the two sides. So I need that angle and that angle. Okay, so two sides in an angle, the angle's got to be in the right spot. Okay, on number 10. Once again, another piece of information that's not marked that we already know is vertical angles again. Anytime the triangles meet at a point, it's always vertical angles. Start paying attention to the patterns. These are the things that we're going to see over and over and over again. Okay, and that's a good thing. That means it's going to be easier for us to prove these things if we see those things. Is that enough? 3 pieces is maybe not always enough. Well, here we have an angle, and we have a side. So this would be an angle, angle, side. Okay. Okay, number 11. What additional piece do we know? Reflexive. Okay. So how many pieces do we now have? We have 2, right? We have an angle and we have a side. Okay. What other piece of information can we prove other than those 2? Nothing. Okay. Once again, some people were trying to tell me that these 2 angles were congruent or that these 2 sides are congruent. We don't know. Okay. We just don't know. Okay. Could they be? Probably. We just don't know. So this is the other one. Only has 2 pieces. 2 pieces is never enough. Okay. This one here. We see parallel lines again. Parallel lines is really important. Okay, parallel lines tells me that we have relationships like this, where we have all kinds of angles that we can prove. But we got to make sure we prove the right angles here. So for instance, these 2 angles are what kind of angles? Alternate interior. Okay, so if that was the case, do we have enough information right now to prove it? No, but we have vertical angles. Sophia?
Could you, like, put the alternate interior angles, like, on the opposite way, so like the bottom and the top? Like
These
that-
2?
Yeah, if I do that.
Could you? What do you think?
I don't know.
Okay, so let me ask you this. What if I had 2 parallel lines? And let's say I have a line going this way. Okay, are these 2 alternate interior?
No. Yeah.
Yeah, they would be. Yeah.
Yeah.
What if I draw a line going the other way? Are these 2 alternate interior?
Yeah.
Yeah. Okay, and that's kind of what we got going on here, right?
What is the, like, line that's like intersecting them?
Yeah, so, yeah, and if I drew this line to intersect, then you could do it that way too. But I didn't draw it that way. But if I were to do this and that, would these 2 be congruent?
Yeah, that makes sense.
Yeah, they're alternate interior because these 2 are parallel.
Okay.
So basically what you have to have is you have to have 2 parallel lines and then you got to have the transversal between those 2. Okay? One thing, so you're right, these would also be congruent here as well. Here's another one that we've seen a little bit. So on this one, actually all 3 angles are congruent, right? We also have a side that's congruent. And we have another pair of sides that are congruent. We have 5 pieces of information here, right? We have way more than we need. And you probably don't need to do all 5 of those. But The reason I bring that up is because we could do angle, side, angle. What else could we do? We could do side, angle, side. Can we do side, side, side? Do we have all three sides? No. Okay. Can we do angle, angle, side? Yeah. Can we do the HL theorem? No 90-degree angle, right? Is there anything called the angle, angle, angle theorem? No. Three angles is not a theorem. Got to have at least one side, okay? So you can never use all three angles. So you could use any of those three, but there are some things that you won't be able to use as well. So that would be one where more than one thing works. You don't have to have one particular theorem there that works. Okay, so that's just kind of like some quick reference. Use that to kind of go back and look at. Today, I'm going to basically kind of look at some people have struggled with, and this might be more of what you're thinking. If I tell you that this and this are parallel, but we don't know necessarily about these two sides being parallel, then what pair of angles could we prove? Well, the only one we can prove would be this angle and this angle. So it has to be the angle between the parallel lines and the transversal. I don't necessarily need these two. I would need to know these two lines are parallel. So the angle touching the line that's not parallel, we don't know this. But the one touching the parallel lines, we know this is parallel. And we've seen that before, where maybe the top and bottom are parallel, but maybe not the sides. Okay. So but it's a good question.